Baalbek in Lebanon is home to stones so massive, 800 to 1,000 tons each, that history says only the Romans could have moved them. Yet, artificial intelligence has just revealed precision in these ancient blocks beyond anything ever seen at the site, millimeter-perfect joints that challenge every engineering certainty. If modern cranes could barely attempt this, then who or what truly built Baalbek? The answers unearthed by AI now raise questions that the official story can no longer ignore. What has technology exposed about Lebanon's greatest mystery that we were never meant to find? At the heart of Baalbek, the stones themselves overwhelm the senses. Locals call them by names that echo their legend: the trilithon, 3 blocks each tipping the scale at around 800 tons, and the stone of the pregnant woman, a single unfinished giant in the quarry, estimated at nearly 1,000 tons. These are not just large stones, they are, by every modern standard, impossible stones. Each block stretches over 19 meters long, longer than a city bus, standing more than 4 meters high and just as wide. The weight alone is staggering. A single trilithon stone outweighs a fully loaded Boeing 747. The stone of the pregnant woman, still partly embedded in the earth, dwarfs even these. Its mass so great that no modern crane in Lebanon could lift it today without months of preparation and custom equipment. The sheer volume of limestone cut and shaped with almost geometric perfection sits stacked on a platform 7 meters above the surrounding valley floor. There are no ancient machines, no pulleys or levers left behind, just the silent, seamless faces of these blocks. Joints between stones are so tight that, in places, even a razor blade cannot find a gap. No ancient text describes how such masses were moved, let alone positioned with this kind of precision. The question hangs over the site: how did any human, ancient or modern, transport and fit stones of such impossible scale? The mystery only deepens as technology turns its gaze on these megaliths, promising answers but delivering only more impossible numbers. Archaeologists tracing Baalbek's story begin with the Romans. In the official record, construction of the grand temples and their massive stone platforms begins around 60 CE during the reign of Emperor Nero. Roman engineers, famous for their ambition, are credited with transforming the site into a showcase of imperial power. The Temple of Jupiter rises atop a colossal podium, its columns soaring over 20 meters high. Beneath the visible grandeur, the ground tells a deeper story. Excavations reveal layers of habitation stretching back thousands of years. Pottery shards and stone tools unearthed in the soil point to Neolithic settlement as early as 10,000 BC. Phoenician and Hellenistic remains intermingle with Roman masonry, creating a dense palimpsest of human activity. Yet, the official narrative holds firm: the most monumental stones, including the trilithon, are attributed to the Romans, using techniques inherited and refined from earlier cultures. Institutional archaeologists describe a progression: Canaanite sanctuary, Hellenistic shrine, Roman temple, each new civilization building atop the last. Written records from the Roman era are sparse, but coins, inscriptions, and the style of construction anchor the Orthodox timeline. The Roman explanation remains the basis for guidebooks and academic reports. Still, the sheer size of the megaliths and the depth of earlier habitation raise questions that the standard chronology cannot fully answer. The accepted account stands, but its foundations rest on a mix of evidence and assumption, leaving room for doubt as new methods challenge old certainties. Dr. Karim M. waited until the last tourist had drifted out of the temple shadows before stepping onto the ancient platform. The official agreement, signed after months of negotiation with Lebanon's Directorate General for Antiquities, allowed his team only a handful of nights, always after closing, always under strict supervision. The terms were clear: no drilling, no sampling, no disturbance. Every instrument brought onto the site had to pass inspection, its use logged and witnessed. The stakes were high, not just for the site's integrity, but for national pride. Rumors had already circulated about foreign researchers smuggling data or damaging ancient stones. Karim, whose own grandfather once guarded Baalbek's gates, insisted on full transparency with local authorities. He brought in partners from a European AI lab and a Japanese 3D imaging company, each sworn to secrecy until results could be verified. The scanning equipment, packed in anonymous black cases, was assembled only after midnight. Laser arrays and photogrammetry rigs swept the podium and the trilithon stones, recording billions of data points without touching a single grain of limestone. Every scan session required a signed log and a government escort. Even so, the team worked in hushed tones, aware that a single misstep could shut down the project or spark a diplomatic incident. For Karim, the real challenge was not the technology, but the politics of access, balancing the promise of discovery with the weight of centuries-old suspicion. The data they gathered would soon challenge everything written in the guidebooks, but for now, the work remained a closely guarded secret, hidden behind locked gates and the silence of the stones. The first results landed like a thunderclap. In a conference room packed with archaeologists and engineers, the AI-powered scans flickered onto the screen. Numbers scrolled across the display, joint gaps along the trilithon platform registering at under 2 millimeters, sometimes less than 1. The data left the room in silence. No one had expected tolerances this tight, not at this scale. A block weighing 800 tons, stretching nearly 20 meters, set so precisely that its seam could barely admit a human hair. For a moment, the experts simply stared, some shaking their heads in disbelief. A senior structural engineer from Berlin leaned forward, asking to see the raw data. A Lebanese heritage official whispered that even the great Roman monuments of the Mediterranean showed nothing like it. The AI's point cloud, built from billions of measurements, revealed a fit so exact that thermal expansion and seismic drift over centuries had barely disturbed the original assembly. One skeptical archaeologist demanded a second round of scans, muttering about calibration errors and the need for independent review. Others sat back, stunned as the implications sank in. If these numbers held up, the foundation of Baalbek was not just massive. It was engineered with a precision that defied every known method from the ancient world. The call went out for replication and peer validation, but the sense of awe lingered. The data had done what centuries of speculation could not. It forced even the most cautious experts to admit that something at Baalbek simply didn't add up. In the summer of 1996, a group of engineers and archaeologists from Germany, Lebanon, and Japan gathered at the edge of Baalbek's ancient quarry. Their goal was simple in theory: move the stone of the pregnant woman, or at least shift its 1,000-ton mass by a few centimeters, using only tools and methods available to the Romans. The team brought timber sledges, ropes, and levers modeled after ancient designs. The air was thick with anticipation as they assembled their apparatus, checked calculations, and assigned roles. What followed was a lesson in humility. The first attempt ended almost immediately. One of the main sledge beams snapped under the weight before the stone even budged. The replacement, reinforced with modern bolts, fared no better. Ropes frayed and anchors tore loose from the ground. Measurements taken after hours of effort showed zero movement. Even with a crew of 24 engineers and local workers, and every safety precaution, the block remained stubbornly fixed as if welded to the earth. Field diary notes from that day describe a growing sense of frustration. One German engineer, exhausted and defeated, wrote that the forces required were orders of magnitude beyond anything the Romans could have summoned. By sunset, the team packed up their tools and admitted defeat. The experiment didn't just fail, it collapsed under the scale of the challenge. Any hope that the mystery would yield to brute force or clever engineering evaporated on that dusty hillside. The stone had not moved a millimeter. Digital simulations brought a new layer of scrutiny to Baalbek's engineering puzzle. Lead simulation engineer Dr. Lena Hofstadter and her team constructed a virtual model of the trilithon, inputting every known parameter, block weight, dimensions, friction coefficients, soil stability, and the incline from quarry to podium. The numbers were unforgiving. Moving an 800-ton stone horizontally, even with ideal timber sledges and a perfectly packed roadbed, required a continuous force of more than 400 kilonewtons, far beyond the sustained output of any ancient labor force. Adding lubrication or more workers only delayed the inevitable. Sledges would shatter, ropes would snap, and the ground itself would deform under the load. Stress calculations showed that even modern synthetic ropes would be at their limit, while the limestone blocks risked fracturing under uneven pressure. The simulations then tested the scenario with modern cranes. Only a handful of the world's largest crawler cranes could theoretically lift a single block, and only on a flat, reinforced surface with months of site preparation. Baalbek's uneven terrain and the tight confines of the temple platform made such a feat nearly impossible. Dr. Hofstadter's report concluded, "Our best machines can barely manage these stones under laboratory conditions. In the real world, the logistics break down long before the stone ever leaves the quarry." The digital models left little room for optimism. Every method, rollers, sledges, ramps, cranes, collapsed under the scale of the task. The data pointed in a single direction. Whatever method was used at Baalbek, it was not one known to modern engineering. Legends swirl around Baalbek's origins, filling the gaps left by history with stories that feel as solid as the stones themselves. In the streets of Baalbek, elders quietly recall tales passed down for generations, stories of builders who were not Roman, not even Phoenician, but beings from an age before the flood. Some say the stones would sing when the right chant was spoken, vibrating and shifting as if weightless. French colonial ethnographers once recorded local masons whispering about wise men who moved rock with sound, not muscle. The idea sounds impossible, yet the scale of the trilithon draws out these ancient memories every time a new visitor stands in awe. Independent researchers, often dismissed by mainstream archaeology, pore over Sumerian tablets and ancient texts. They point to the name Baalbek in stories as the landing place, a site where gods or giants first set foot on Earth. The Anunnaki, figures from Mesopotamian myth, are said to have chosen this spot as a gateway between worlds. Some theorists map these claims onto the stones themselves, suggesting that the very layout of the platform encodes a message or purpose lost to time. The appeal of these alternative narratives is not just their mystery, but their power to explain what conventional history cannot. In a world where no tool marks match and no Roman boast survives, the legends step in to fill the silence. For many, the impossibility of Baalbek is not a puzzle to be solved, but an invitation to imagine what knowledge might have been lost, and what secrets the stones still guard beneath their ancient weight. In early 2021, a confidential memo circulated through the offices of Lebanon's Directorate General for Antiquities. The subject: unexplained anomalies detected beneath Baalbek's main platform during a routine geotechnical review. Ground-penetrating radar, brought in under a heritage conservation grant, had mapped a series of sharp-edged voids and corridors running beneath the Roman-era foundations, rectilinear spaces that didn't match any known plans. Internal emails reveal a split among officials. Some argued for immediate public release, seeing a chance to boost Baalbek's profile and attract global research funding. Others, wary of destabilizing the site or inviting controversy, insisted on silence until structural risks could be assessed. The Directorate's senior engineer warned that drilling or excavation could trigger collapse in areas already weakened by centuries of earthquakes. Meanwhile, outside experts pushed for access to the raw data. Requests from foreign universities and independent researchers were logged, then quietly shelved. Rumors of hidden chambers and lost archives began to circulate online, fueled by leaks and anonymous tips. At a closed-door meeting, one heritage official cautioned that any admission of non-Roman structures could invite political headaches, not just academic debate. The standoff left the data locked away, and the story of what lay beneath Baalbek's stones became another layer in the mystery, a secret not just of the past, but of the present. In the absence of answers, speculation thrived, and the question of what institutions might be hiding became as much a part of Baalbek's legend as the stones themselves. In 2023, a team of AI analysts from Lebanon, Germany, and Japan fed block-by-block measurement data from Baalbek into pattern recognition algorithms. The results didn't just confirm local anomalies, they flagged geometric signatures that matched those at Pumapunku in Bolivia and the core blocks of the Great Pyramid. Distances between key points, angles of cut, and even the ratios of block dimensions clustered far closer than chance would allow. When the study's lead statistician published the first summary online, the academic backlash was immediate. Some reviewers accused the team of seeing shapes in clouds, dismissing the correlations as statistical artifacts or the product of overfitting. Others, including a handful of structural engineers, called for urgent collaboration, arguing that the findings demanded open, global investigation. Internal emails from a major European university revealed heated debates over whether to even acknowledge the study in formal publications. The pushback wasn't just about numbers, it was about the threat to established narratives. Institutions that had long staked their reputations on Roman ingenuity now faced a dataset that didn't fit the script. The AI study's raw data showed block tolerances at Baalbek, Pumapunku, and Giza converging within millimeters despite differences in material and culture. The research team, frustrated by the refusal of major journals to publish their work, began releasing anonymized data sets and code, inviting outside scrutiny. The controversy spilled onto social media, where independent researchers pored over the numbers and demanded transparency from the institutions holding site access. The call for multinational, open access research grew louder, fueled by the sense that Baalbek was not just a local mystery, but part of a global enigma that mainstream archaeology seemed unwilling to face. Baalbek's trilithon stones, each weighing around 800 tons, remain unmatched in recorded ancient construction. Archaeological layers show human activity at this site dating back to 10,000 BC, yet the precise origin and purpose of the megalithic foundations are still unproven. Recent engineering simulations confirm that even today's technology struggles with moving such massive blocks, and no Roman-era records explain their placement. While emerging 3D scans and pattern studies highlight millimeter-level precision, no peer-reviewed evidence yet reveals the full method or motive behind Baalbek's creation. Institutional reluctance and classified ground surveys mean key data is still out of public reach. As of now, the facts show that Baalbek's scale, precision, and endurance defy both conventional timelines and modern capabilities. The site stands as an enduring challenge to our understanding of ancient engineering, inviting open research and continued scrutiny.